Hello, I'm Rupa Keswami, working as Assistant Professor in the Department of Electronics and Communication, SJBIT. I welcome you to Microprocessor Lab. Now I'm going to demonstrate how 7-segment display is interfaced with 8086 trainer kit and messages displayed on it. 7-segment display are of two types, common anode and common cathode. The board we are using is a common anode type. In a 7-segment display, we have 8 LEDs. In common anode type, we have all 8 LEDs commonly connected to value of 1. If we want some LED to glow, then we have to send the other terminal as 1. Now we shall see how the execution of a program is done. Coming to its connectivity, you have to connect 7-segment board with the 8086 trainer kit. We have 4 display unit on which I can display a message. In our program, we are displaying 2 messages, that is cool and help. We shall execute our program. Go to start, run, give CMD to open command prompt, say OK. Enter into your folder CD space desktop. I've already explained how folder is created in LDR video. I'm going to type my code in the folder 7-segment. To type the code, give command edit space file name. File name given is 7seg.asm. Extension is important. Enter. You will get an empty window where you have to type the code. Once you have typed the code, go to file and save. Coming to program, here we are originating from 2000H and these lines will help us to configure our 8255 as a output port. Then in this line we are mentioning SI, that is source index register, as 2100 address. This is 2100 address where we have actually loaded 7-segment value of the message to be displayed. FF means that we are sending 1 on a cathode of all LEDs. Means what? It will not glow. Means first line will be a blank. Then we are sending next line character as C6, C0, C0, C7, which is for cool. C6 is a 7-segment value for C. C0 is a 7-segment value for O. Similarly, the others. The calculation of this will be explained in theory. Since we have 3 lines to be displayed, we have to initialize our CL register as 3. It depends on number of lines you are displaying on the 7-segment. Then we have CH register, which is given as 4. It is fixed because we have 4 display units on the board. For each character we have 8 bits. So BL is written as 08, means 8 bits value to be sent. Then we have to read, in bracket SI will read a content of 2100 onto AL register. Then increment SI for next character. Then we have to rotate our AL value. AL is having a message to be displayed for a first character. Then we have to rotate it left and go with bit by bit value sent. So value is sent through port B. FFE2 is for port B, and on every value sent I need to send a clock on port C. Hence we are sending AL as 01 on to port C and we are decrementing AL, that is 0, and we are sending on the port C for sending a clock. So on every bit sent I'm sending a clock, and we have to decrement BL, that is 1 bit is sent, and loop 1 is continued until all 8 bits are sent. Once all 8 bits are sent, this instruction is false. It goes to next instruction where it says decrement CH. CH is having number of characters. 1 character display is sent, so we are decrementing it, and until CH is 0, we are looping back to loop 2. So loop 2 again starts with ABL 08, that is in a second character again all 8 bits to be sent. So this continues until all characters are sent. Once all characters of a particular line is sent, we are coming out of this loop and we are calling a delay. Delay is to create some time difference between one line to other line display. This is the delay program where we are pushing our CX content, because if we have used CX, its data will be lost in the subroutine. Hence we are pushing it, and then then we are inserting some delay through looping, and we are popping out CX before we return into main program. Once we return to our main program, we are decrementing CL. CL is actually having number of lines. Once one line is already displayed, it is decremented. This loop goes for the second line too. Once all lines are displayed, CL becomes 0, this instruction is false, and it goes to next instruction where it says jump short, loop 4. So loop 4 will again start with the character that we are loading. So it continuously displays the message we are loading in this table. Now save the file, exit, assemble the code with the help of command x8086, give file name is 7sec.asm, enter. There are no errors. If any errors, edit and debug. Link the file with the command link86. Don't give any file name here, enter. Give file name 7sec, don't give any extension, enter. Until you get message saying exa file is generated. So extended Intel exa means exa file is generated. There are no linking errors, so I can now execute my code. To execute code, we have to first switch on our power supply. Once we switch on power supply, go to start, go to program, ESA trainers, Win86E. It opens as the package. Click on download to download exa file, browse. Exa file is present in 7 segment folder. Go to your folder, select exa file, open, say OK. It starts downloading your program from PC onto trainer kit through this serial port. Now I need to set program counter. Go to set PC, enter starting address 2000, say OK. Since it is an output device and we want no command to be displayed, we can go with run program. So click on run program. So you can observe output on the 7 segment display where you could see blank, then cool, then L is the message displayed. So display will be happening continuously until we press reset. So to stop, you can press reset. This is how 7 segment display can be interfaced with 8086, and we have a message displayed on it through our program. For Viva, you have to understand how 7 segment display construction is done, its working principle, what are the different types, and its usage. Thank you.